Now if you just see like simplification after this, we will do something like this, and we will get you can just go through this, you will just get this this as a result. Now we are talking about dl by dv, right? So dl by dv here is this one, so we are going to substitute this over here. So dl by dz, whatever we have gotten till here, this result we are going to substitute in over here. So this is actually k, so for in respect to I we can just substitute I d yi hat minus yi. We will just keep it over here, as you can see, and we are left with this dzi by dv. That is simple. Zi is nothing but vht, so we will just differentiate, we will get ht. So overall we will get this result, outer product of two vectors, and these are the dimensions. You can just follow up, you can just see those. Now further we are going to check C dl with respect to dw. So we have just found dl with respect to dv. Now we will see what will be the loss with respect to weights. Now we are going to find loss with respect to w, and as you know, as we have done for v also, each timestamp we are getting losses. So but weights are same, w is same throughout the network, u is same throughout the network, v is same throughout the network. So here we'll just going to total loss, we are going to like sum it up through all the losses at each timestamp with respect to same weight, and that is nothing but summation of this. And these are the equation again we have seen, familiar equation, I think for from now you will be familiarized with that. So again the summation, so we are going to find this. So we know that h1 is nothing but just substitute in the place of t1, you will get this in categorize equation a1. So loss with respect to L1, just we will see for L1, this thing we are just going to see for now. That is nothing but loss with respect to L1 is nothing but, again I am telling from y, like yi, I am showing generalized version, yt, we will from ht we are going to find yt, right? Here we have weight v, and ht is found with respect to w. So in forward propagation we need to first find ht, that means we need to get w, and then from ht we will find yt. Vht is nothing but z, and from z we are going to find yt. With respect with y we will find l. So in back propagation we should go in back. So whatever the loss like dl by dy t hat, whatever will be the loss we have calculated like derivative, that should be propagated to w, because this vt is independent. So whatever changes we are doing, this like what are these things has been changed. So this change like dl by dyt should be back propagated to previous things from where it went. So this is forward propagation and this is a backward propagations. So whatever the dl with respect to dyt should be reflected in here, as you can see, dl by dw. So whatever the changes we have will be back propagated to v, that in turn ht, that will be back propagated to w, because ht is dependent on w and w is independent in this term. So the same case is going on here. dl1 by dw here is nothing but is dl1 by dy1, that in turn dy1 by dh1, because y1 is dependent on h and it is independent, obviously vice versa, and dh1 by dw, because w is over here independent and this is dependent on w. So as a chain rule, if we just cancel out, we will get dl1 dw. So what in all I want to just say is, whatever the like output side, whatever the derivatives we get, it should be back propagated to input side. So w is something like input side, that means this thing I'm just simply saying like that. Input side is this, the output side means this. So we need to back propagate this information. As in forward propagation, how will forward propagate the information of input to output? So same case, the derivatives of output should be back propagated to here, so that we can find loss with respect to w or loss with respect to initial weights or inputs for suppose. So like this we will get, and the values for this is yt by yt hat, as we have seen previously also, and this loss is this thing we have seen previously, and dh1 by dw is this thing, because h1 is over here. If we will just find the derivative of tan h square is 1 minus tan h square, and we will get h naught because we are finding with respect to w, so it will come out as a result of derivative.